So now that we've gone over the different types of numbers here, we're going to look at some application problems. So for this first one, all we have to do is be able to read this chart over here on the side. So let's see if we can maybe zoom in a little bit. So we've got this table over here that talks about the rate of change of these different professional jobs. So we want to know the greatest change. Now, what to keep in mind about this is that by greatest, it doesn't mean if it's an increase or a decrease, just the most change. It can be the most decrease or the most increase. So it's almost kind of like you're thinking about, if you remember, absolute value. So not really the sign. So we would just think about this being 25.1, 31.8, and 42. They're a decrease. That negative means decrease, but the amount of the change would have been 42 for that locomotive firers. So the greatest change would be right here with the personal care aides, the 48.8. So that would be the occupation with the greatest change. And it is positive, so that is a growth. But the positive and negative don't really affect our answers. They just tell us if that change is a growth or a decrease. So which occupation has the least amount of change? Again, we're not looking at, it's not necessarily has to be a negative number. We're looking at the absolute value of each one of these. So if we were to look right here at the word processors and typists, we would say that that was a 25.1% change. It was a decrease because of that negative, but that would be the least change. So that would be the word processors and typist. Here we go. All right, the rest of these are going to go back to use kind of those definitions that we looked at when we were looking at the different types of numbers. For these two, there are lots of different possible answers, so I'll just list some possible answers. We want to give it one number between -6 and 6 that is an integer that's not positive. So if you're not positive, then you are negative. So we want an integer that is negative, or technically you could be 0. 0 is also not positive. So I could pick a negative integer, maybe -5. You also could pick 0. We can't have decimals, we can't have fractions, because those aren't integers. So remember, the integers are all the natural numbers, their inverses, and then also 0. Let's see, a rational number that's not whole. So remember, by not whole, the whole numbers start with 0 and go on up to infinity. No decimals, no negatives, no fractions. So a rational number that is not whole. So we can think of anything that's basically not in this list. So if you think of anything that is negative, that would work. So again, we could use -5. If you think of any fraction, whether it's positive or negative, or we could do some decimals. And again, those could be positive or negative there. So lots and lots of possible answers we could have. Let's look at a few more ways we could ask questions in the applications of this real number system. For this one, I'm going to get you started, and then I'm going to have you guys give it a shot. For this, we've got a list of numbers here. We're going to classify which of these are natural numbers. Now, the square root of 25 reduces down to 5. The square root of 2 does not reduce down. And you can check that in your calculator. If you type in the square root of 2, you're going to get this awful looking decimal. If you type in the square root of 25, it's going to give you 5. So that's how I know which one reduces and doesn't reduce. So thinking about the natural numbers start with 1, go on to infinity. No 0, no negatives, no decimals. So the only natural number up here is the square root of 25. Or you can list 5, either way. Now, all natural numbers are whole numbers. So the square root of 25 is also a whole number, plus 0 is also a whole number. So this list are going to keep growing bigger and bigger and bigger. So it's not just use a number one time. You're going to keep reusing numbers. So go ahead and hit pause and see if you can finish classifying these numbers for this example. All right, let's see how you did. All whole numbers are integers, so I'm going to write these down. Plus, I'm going to pick up any of the negative inverses that we might have here. So still no fractions, no decimals. So the only thing I would pick up is -5. So I've got -5, 0, square root of 25. Rational numbers are all those integers, so everything we had before. Plus, I'm going to pick up fractions, whether they're positive or negative, and then decimals that terminate, like this one here, it terminates. Let's see, there we go. Get my pen back. 5.8, or if they had that repeating decimal. Now, irrational numbers are the only ones that we're not going to see this list growing. You cannot be rational and irrational. You are one or the other. There's no number that falls into both these camps. So that means the only irrational number is the one we haven't used, the square root of 2. And then all the numbers that we're dealing with are real numbers. We're not looking at anything that doesn't fall into the real number system because we're only doing real numbers. So they're all real numbers, or you could write them all out. Last one down here, true or false. Decide whether each statement is true or false. Every whole number is positive. Just to remind ourselves, the whole numbers start with 0 and go on up. A lot of people would say this is true because they don't see any negatives, but I already went up here and told you that 0 is not positive. So this is false. 0 is not positive. All right, go ahead and take a quick pause and see if you can, wager a guess on B here. All right, if you didn't get a chance to think about it, remember to hit pause and go ahead and get your guess down there, and then we'll go over it. Every rational number is a real number. That's true, because we're only considering the real number system. We're not looking at the complex numbers or imaginary numbers. So it doesn't matter what I would put here. I could put integer, whole, natural, irrational. Doesn't matter which one I put here. They're all real numbers.